Okay guys, let's begin the discussion over the questions. The solution set of this inequation is going to be what? So let's begin the solution solving. It is 5x minus 2 upon 3 minus 7x minus 3 upon 5 is greater than x upon 4. How do you begin with the solution? You basically compute the LCM. On the left hand side, you get 15, 5 is multiplied by 5x minus 2, 3 is multiplied by 7x minus 3, whole upon 15 is greater than x upon 4. Then you have what? 25x minus 10 minus 21x plus 9 whole upon 15 is greater than x upon 4. Now 25 minus 21 gives you 4x, minus 10 plus 9 gives you minus 1 upon 15 is greater than x upon 4. You can very easily cross multiply. 4 is positive, so you get 16x minus 4 is greater than 15x. Or you are getting 16x minus 15x is greater than 4. So x basically belongs to open 4 to infinity. X is all the real numbers strictly greater than 4. That means x lies in this interval open 4 comma infinity, and therefore 4 comma infinity is its solution set open interval. Question is that this solution set contains 2 comma infinity. So if I talk about the solution set, somewhere here is 4, then hollow circle at 4 up till infinity, this is the solution set. That's the solution set. Now it is saying it contains 2 comma infinity. Now 2 comma infinity begins from here, somewhere here. So no, this portion is not in the solution set. So complete 2 comma infinity does not lie in this interval. So this is wrong. Contains minus 1 comma infinity. Minus 1 would be somewhere even before here. So here this complete portion is not lying in the solution set 4 comma infinity. Therefore minus 1 to infinity completely is not contained in my solution set. It contains 5 comma 6 closed interval. 5 comma 6 would be somewhere here. This is 5, this is 6. Yes, this portion is completely lying in 4 comma infinity. So yes, and contains 5.5 comma 7.5. It would be somewhere here, 5.5 to 7.5 suppose. Again, it is completely lying in the solution set, so D is also true. Moving to the next question, let's see what we have. Consider this inequation, then there is statement 1 and statement 2. Let's first of all talk about statement 1. It says 2 is lying in the solution set of this inequation. Next says 4 lies in the solution set. So for that we basically need to first compute the solution set. I have 2x plus 4 whole upon x minus 1 is greater than equal to 5. Clearly I will be interested in bringing it to the left hand side. This is 2x plus 4 upon x minus 1 minus 5 is greater than equal to 0. So this becomes 2x plus 4 minus 5x plus 5 upon x minus 1 is greater than equal to 0. 2x minus 5x is minus 3x, and this is plus 9 upon x minus 1. You can take out minus 3 common. You have x minus 3 whole upon x minus 1 is greater than equal to 0. You can multiply both sides by minus 1. You basically get 3 times x minus 3 upon x minus 1, and this is going to become less than equal to 0. When you multiply both sides by negative quantity, the inequality changes, it reverses. Now 3 is positive. Positive into something is negative. That is only possible when that something is negative. If this thing also was positive, positive into positive would have been positive. So this implies x minus 3 upon x minus 1 is negative. Now what are the x's for which this holds? This is 1, this is 3. If you plug in anything less than 1, you get negative in the numerator, negative in the denominator, which basically makes it positive. If you plug in anything between 1 and 3, strictly between 1 and 3, you basically get positive Here you get positive, here you get negative. Negative upon positive gives you negative. Anything greater than 3 is obviously going to give you positive again. If you include 1, so basically first of all our favorable region is what? This is the favorable region, because whenever x is coming from this region, x minus 3 upon x minus 1 is negative. But equal to 0 is also allowed. Can I take 1? No. When I take 1, my denominator is not defined. The denominator becomes 0, so my expression is not defined. It's not a real number. So I definitely cannot take 1 in from this region. But I can take 3 very nicely, because when I plug in x equals 3, denominator is positive and numerator is 0, so this expression is 0 and taking 0 is allowed. So for whichever x's I am getting this to be equal to 0 are also going to lie in my solution set, because I am saying all those x for which this is either less than 0 or equal to 0, and for 3 it is equal to 0. So my solution set is 1 open, 3 closed. 1 open, 3 closed is the solution set. So yes, 2 lies in the solution set, but 4 does not lie in the solution set. So statement 1 is true and statement 2 is false. Moving to the next question, we have solve the following system of linear inequations. What is it that we get? Let's talk about this now. So there is a system of linear inequations given to us. 3x minus 6 is greater than or equal to 0. This means 3x is greater than or equal to 6. X is greater than or equal to 6 upon 3, which is 2. Why? Because 3 is positive. This is the solution set for the first inequation, that is closed 2 comma infinity. And next we have 4x minus 10 is less than or equal to 6. That is 4x is less than or equal to 6 plus 10, that is 16. X is less than or equal to 16 upon 4, which is 4. So the solution set is basically minus infinity to 4 closed. What is the solution set of the complete system? Complete system solution set is the intersection of the solution sets of the two linear inequations in the system, or which make the system. So here I have 2 to infinity, so somewhere here is suppose 2. So including 2 to infinity is the first solution set, and minus infinity to 4, so somewhere here included 4 is there. So minus infinity to 4 is the second solution set. Very clearly intersection is this. This region is being covered in both the solution sets. Intersection is closed interval 2 to closed 4, and therefore solution set of the system is this. It is 2 comma 4. Clear? Moving to the next one, we have solve this inequation. Now in here, mod of 3x minus 2 is less than or equal to half. Now here, if the concept is clear to you, that when I say mod of a minus r is less than or equal to b, that means a minus r is greater than or equal to minus b less than or equal to b. So a is greater than or equal to r minus b less than or equal to r plus b. If this concept is clear, it is very easy to understand that 3x minus 2 is less than or equal to half will be interpreted as 3x minus 2 is greater than or equal to minus half and less than or equal to half. So obviously 2 is going to be added. I get 3x is greater than or equal to minus half plus 2 and 2 plus half. So this becomes what? 4 minus 1 is 3 by 2 is less than or equal to 3x is less than or equal to 5 by 2. Now if you divide by 3, you basically get what? 1 by 3. You can do that because 3 is positive, inequality is not going to change. So 3 by 2 upon 3 is less than or equal to x is less than or equal to 5 by 6. So your solution set is coming out to be 1 by 3 comma 5 by 6. So here if I say this is 1 by 2, not 1 by 3, because 3 is going to get cancelled with 3. So this becomes 1 by 2. 1 by 2 to 5 by 6 is my solution set. Now I have the next one, solution of the following system of inequations. So there is a system of inequations again involving modulus. So let's talk about now that. What does it say? It says mod of x minus 1 is less than or equal to 5. Solution of the system is the intersection of the solutions of the inequations involved in the system. So the first inequation is mod of x minus 1 is less than or equal to 5. I just told you This means x minus 1 is greater than equal to minus 5 less than equal to 5. That means x is greater than equal to minus 5 plus 1, which is minus 4, less than equal to 5 plus 1, which is 6. So the first solution set is minus 4 to 6 closed interval. And second is mod x is greater than equal to 2. Okay? Mod x is greater than equal to 2 is interpreted how? That means all those real numbers whose distance from 0 is greater than 2 or equal to 2. So I can write it like this. Now all the numbers, real numbers whose distance from 0 is either greater than 2 or equal to 2. So all these numbers and all these numbers are the numbers whose distance from 0 is greater than 2, and these are the numbers whose distance from 0 is equal to 2. That means x is either less than equal to minus 2 or x is greater than equal to 2. That means x belongs to minus infinity to minus 2 closed interval or 2 to infinity. So when you take the intersection of both these solution sets, you have what? So somewhere here is minus 4, then there is minus 2, 0, 2, and say somewhere here is 6. I am saying from minus 4 to 6, okay, including these 2 points. And then there is minus infinity to minus 2, including this, and 2 to infinity. So you can very easily see this happens to be the intersection, this and this. So it is minus 4 to minus 2 union 2 to 6. So answer is what? Minus 4 to minus 2 union 2 to 6. Clear? Minus 4 to minus 2 union 2 to 6. Let's talk about the next question. All pairs of consecutive odd integers, positive ones, both of which are smaller than 18, such that their sum is more than 20 are what? Okay. So among the options, we have to select those pairs of consecutive odd positive integers, both of which are smaller than 18, such that their sum is more than 20. So if I take x is the first odd positive integer, the next consecutive odd positive integer will be x plus 2. It is given that both of them are less than 18. So in particular, x plus 2 is less than 18. And it is given that their sum is more than 20. X plus 2 is greater than 20. It's smaller than 18 and the sum is greater than 20. So you get x is less than 18 minus 2, which is 16, and 2x plus 2 is greater than 20, that is 2x is greater than 20 minus 2, which is 18, so x is greater than 9. So you are getting x is greater than 9 and x is less than 16, that is x is greater than 9 and x is less than 16. X is what? A positive odd integer. So x cannot take 9, next positive odd integer is 11. Next is 13 and next is 15. So all the pairs are x, comma x plus 2, again then 13, comma 13 plus 2, 15, comma 15 plus 2. Okay? So 11, 13, 13, 15, 15, 17, but not this. These are all the pair of consecutive odd positive integers, both of which are smaller than 18 and their sum is greater than 20. Next says, what is the region represented by this in equations? This is pretty interesting. Let's try to talk about this. Graphical approach is being concerned over here. You need to be thorough with that approach. Mod of x minus 1 is greater than equal to 1 can be interpreted as x minus y is less than equal to minus 1 and x minus y is greater than equal to 1. Just now we did. So here this means this and this you need to basically plot. So first of all, this will be interpreted by x minus y equals minus 1 and here x minus y equals 1. If I talk about the plotting, when x is 0, y is 1. When y is 0, x is minus 1. So you basically get a line like this. This is x minus y equals minus 1. Now origin is lying on one side of the line and on the other side of the line origin is not lying. If I put 0, 0, so 0 minus 0 is 0, 0 is greater than minus 1. I want less than minus 1. So all the points on this line will be included because I want equal to minus 1 also, but I want less than minus 1. If I am putting 0, 0, I am getting greater than minus 1. That means everything on the other side of the origin. That means the side of the line, the region which is on the line or above the line, which is not containing the origin, is going to be the shaded region. I am saying that the line will be included along with this shaded region. Next I have x minus y equals 1. When you put x equals 0, you get y equals minus 1. And when you put y equals 0, you get x equals 1. You get this as the equation. This is x minus y equals 1. All the points on this line are actually satisfying x minus y equals 1. I want x minus y equals 1 or greater than 1. Equals 1 is this. What about greater than 1? If you put in 0, 0, you get 0 is greater than 1, which is wrong. So go to the other side. And this is the region which is the lines as well as the shaded region represented by mod of x minus y greater than or equal to 1. No, it's not this. No, it's not this. Yes, it is this. And no, it is not this. Clear? Moving to the next question, we have points which are lying in the solution set of this linear inequations are what? Let's see. Now here, it will be very, very simple to talk about the graphical plotting of this region. 3x plus 4y greater than or equal to 12. So this will be first interpreted as 3x plus 4y equals 12, and next you have y is greater than or equal to 1. So that means y equals 1. So when I plot, what is it that I get? When x is 0, y is 3. When y is 0, x is 4. Okay, so somewhere like this, the line is going to be. When x is 0, y is 3. When y is 0, x is 4. This is 3x plus 4y equals 12. So all the points on this line will be included. Apart from it, I want greater than 12. When I put 0, 0, I get 0 is not greater than 12, it is less than 12. So the other side is going to be shaded, the above side, this side. Right? After this I have y is greater than or equal to 1. For that I want y equals 1. This is y equals 3. So y equals 1 will be somewhere here. This is y equals 1. Y equals 1 I want and y greater than 1 I want. So greater than 1 means on the above side. Right? And also you are given x is non-negative, so only the shaded region has to be in the first quadrant. So I basically get this. The above side of the line, the above side of y equals 1, and in the first quadrant as well. Now it is saying that if this is the solution set, 3, 3 is a point lying in the solution set. Yes, of course, 3, 3 will be lying definitely in the solution set. 0, 0 is not lying in the solution set. 4, 3, yes, it will be lying in the solution set. And 4, 4 will definitely be lying in the solution set. So I have, this is going to lie, this is going to lie, this is going to lie, but this is not going to lie. Next, let's see what we have. The linear inequation for which the shaded region in the figure is solution set is what? Okay. Here if you can see, there are 4 lines which are actually bringing this region into existence. Let's talk about the first line, 3x plus 4y equals 18. Okay, so this line definitely is included, so equality will be there. Now this region is coming under greater than or equal to 18 or 3x plus 4y less than or equal to 18 is what we need to understand. Here if you talk about, there is one region, now this line is dividing the entire plane into 2 halves. This is the first half, this is the second half. The second half is containing origin. If I put 0, 0, In place of x0, in place of y0, I am getting 0 is less than 18. That means this side of the region is 3x plus 4y less than equal to 18. This side would be 3x plus 4y greater than equal to 18. This region is shaded. That means the first inequation is 3x plus 4y less than equal to 18. Clear? Moving to the next, we have this line x minus 6y equals 3. Okay. Now this is again dividing the entire plane into two halves. One contains origin, one does not contain origin. Okay, so now when I put origin 0, 0 in place of here, I get 0 minus 0, which is 0, 0 is less than 3, right? So the region containing origin is represented by x minus 6y less than equal to 3. The region not containing origin, this region, is represented by x minus 6y greater than equal to 3. I don't want this region, I want the other side of the region. So it will be x minus 6y less than equal to 3. After this, I have this line which is 2x plus 3y equals 3. Now this line again is dividing the plane into two halves. One contains origin, one does not. Put 0, 0, you get 0 is less than 3. So the region containing origin is 2x plus 3y less than equal to 3. Not containing origin, which is the other side, which is the shaded side, it is 2x plus 3y greater than equal to 3. And therefore the third one is 2x plus 3y greater than equal to 3. After this, I have this line minus 7x plus 4y equals 14. Again, this is dividing the plane into two halves. One contains origin, one does not contain origin. I am interested in the side which contains origin because that is where my shaded region is sitting. So therefore, if I put 0 over here, 0 over here, I am getting 0 is less than 14. So this side is minus 7x plus 4y less than equal to 14. The other side is, which is not containing origin, it is represented by minus 7x plus 4y is greater than equal to 14. I want minus 7x plus 4y is less than equal to 14. Okay, minus 7x plus 4y is less than equal to 14. And therefore, what happens to be my correct option? 2x plus 3y is greater than equal to 3. 3x plus 4y is less than equal to 18. X minus 6y is less than equal to 3. Minus 7x plus 4y is less than equal to 14. Clear? Moving to the next question, let's see what we have. The region which is represented by 2x plus 3y less than equal to 6. Now here, if I talk about the region first of all, 2x plus 3y is less than equal to 6. First of all, I will be interested in plotting the line 2x plus 3y equals 6. When you put x equals 0, you get y equals 2. When you put y equals 0, you get x equals 3. So somewhere like this, the line will be plotted. This is 2x plus 3y equals 6. Now less than would be this side or that side. For that we need to test for the origins behavior. When you put x equals 0, y equals 0, you get 0 is less than 6. So this is my region. The other side would be greater than 6, okay? Now if this is the region, that means the line as well as the shaded region is the region represented by this inequation. Question is that the region contains the line 2x plus 3y equals 6. Yes, this is the line 2x plus 3y equals 6. It contains the line 2x plus 3y equals 6. It contains the line 2x minus y equals 1. No, it does not. It contains the line x equals 2. So somewhere like this would be when y is 0, x is 3. So somewhere like this would be x equals 2. And it is not containing the line x equals 2 completely. It is not containing the line y equals minus 3 completely. This is y equals minus 3. It is also not containing this. It is only containing one line 2x plus 3y equals 6 according to the options. Okay, so go through all the questions nicely. That's it from my side. Thank you.